Today we talk about Earth motions, so please listen start to end. Thanks. The real movement of Earth through the galaxy. Introduction. When we think of Earth's motion, we often imagine its daily rotation on its axis and its yearly orbit around the Sun. However, Earth's movement is far more complex and dynamic. Our planet, along with the entire solar system, is hurtling through the Milky Way galaxy at incredible speeds, following a complex and fascinating trajectory through space. Earth's motions in space. To fully understand Earth's movement, we must consider several key motions that govern its path through the cosmos. 1. Rotation on its axis. Earth spins around its own axis approximately once every 24 hours, leading to the cycle of day and night. This rotation occurs at a speed of about 1,670 km/h, 1,037 miles per hour at the equator. 2. Revolution around the Sun. Earth orbits the Sun in an elliptical path at an average speed of about 107,000 km/h, 66,600 miles per hour, completing one full orbit every 365.25 days. This motion, combined with the axial tilt, is responsible for our seasons. 3. Solar System's motion around the galactic center. Our Sun, along with the entire solar system, is in constant motion around the center of the Milky Way galaxy. This movement follows a roughly circular path, known as the solar orbit, at an astonishing speed of approximately 828,000 km/h, 514,000 miles per hour. It takes the solar system about 225 to 250 million years to complete one full orbit around the Milky Way, a period known as a galactic year. 4. Galactic drift and movement toward the Great Attractor. In addition to orbiting the galactic center, the solar system itself is moving relative to the surrounding interstellar environment. Our local stellar neighborhood moves toward a region called the solar apex at about 70,000 km/h, 43,500 miles per hour. Furthermore, the entire Milky Way is moving toward a massive gravitational anomaly known as the Great Attractor, a region of immense mass pulling galaxies toward it at speeds exceeding 2 million km/h, 1.2 million miles per hour. The helical motion of the solar system. A common misconception is that the solar system moves through space in a simple circular orbit around the galactic center. In reality, it follows a helical spiral-like trajectory, as the planets orbit the Sun while the Sun itself moves through the galaxy. This motion creates a corkscrew-like path through space, emphasizing the dynamic and intricate nature of our journey through the cosmos. Earth's ever-changing place in the universe. Given these complex movements, Earth is never in the same place twice. Every moment, our planet is traveling through new regions of space, influenced by gravitational forces from both near and distant celestial bodies. Over millions of years, these motions contribute to shifts in the positions of stars and even the structure of our galaxy. Many of us grew up with the idea that Earth simply revolves around the Sun, which remains stationary in space. However, the reality is far more complex and fascinating. As we explore Earth's motion through the galaxy, we discover that our planet not only orbits the Sun but also hurtles through space at an incredible speed, along with our entire solar system. This movement could be linked to some of the universe's greatest mysteries. Scientific hypotheses suggest that Earth's journey through the galaxy may expose us to cosmic rays, which could trigger genetic mutations and contribute to mass extinctions. Additionally, changes in Earth's orbit around the Sun may impact the environment, potentially leading to catastrophic changes such as another ice age. By understanding our planet's movement, we can better appreciate our place in the cosmos and even uncover clues to larger questions, such as the formation of our galaxy and the future of life on Earth. To grasp this concept, imagine being on an airplane flying at a constant speed and altitude. Inside, you wouldn't perceive the motion, as everything appears still relative to you. However, an observer on the ground would see the aircraft moving through the sky. This principle, first described by Galileo Galilei in his 1632 book Dialogue concerning the two chief world systems, illustrates what we now call Galilean relativity or Galilean invariance, the idea that motion is relative and that there is no absolute frame of reference. Depending on the context, different frames of reference may be more relevant for observation. Applying this to Earth's movement, we must first determine our point of observation. From within our solar system, we see the planets orbiting the Sun. However, on a larger scale, the entire solar system spirals through our galaxy, the Milky Way. One well-known example of relative motion within the solar system is Earth's revolution around the Sun. Earth's orbit is not a perfect circle but an ellipse, with the Sun positioned at one of its focal points. This means that at certain times, Earth is closer to the Sun than at others. The closest point, known as perihelion, occurs around January 3, while the farthest point, aphelion, occurs around July 4. These variations contribute to seasonal changes. The typical depiction of the solar system showing the Sun at the center with planets neatly revolving around it is somewhat misleading. In reality, the planets exert gravitational forces on the Sun, causing it to shift slightly. The gas giants, Jupiter and Saturn, have particularly strong gravitational influences that affect the orbits of both the Sun and Earth. When these two planets align even slightly, they exert significant perturbations on all bodies in the solar system. Over time, these minor orbital changes accumulate, leading to long-term climate shifts known as Milankovitch cycles. One key aspect of the Milankovitch cycles is the variation in Earth's axial tilt, which oscillates between approximately 22 and 24.5 degrees over a 41,000-year cycle. This shift alters the distribution of solar radiation across the planet, influencing the timing and severity of glaciation periods, or ice ages. Based on these cycles, some scientists predict that Earth may be on the brink of another ice age, which could last for tens of thousands of years. By studying Earth's movement through the galaxy, we gain insights into our planet's past and future. This knowledge not only enhances our understanding of the universe but also helps us anticipate potential environmental changes, allowing us to better prepare for what lies ahead. The effects of anthropogenic climate change are currently disrupting Earth's natural climate cycles, making it difficult to predict the exact timing and intensity of future ice ages. Earth's movement within the solar system is already complex, but its journey through the Milky Way is even more intricate. The Milky Way is a vast and dynamic galaxy, spanning over 100,000 light-years in diameter and composed of countless stars, gas clouds, and dust. One of its most fascinating features is its rotation. Like a colossal spinning windmill, the galaxy's spiral arms trail as it spins. This rotation causes stars and gas to move in circular orbits around the galactic center. Earth resides in one of these spiral arms, approximately 25,000 light-years from the center. In the solar system, the Sun's gravity dominates, governing the orbits of planets and other celestial bodies. However, the Milky Way lacks a single dominant gravitational source. Instead, its gravitational field is shaped by the combined mass of all its components, making it challenging but rewarding to track their motion and uncover the galaxy's intricate structure. Just as Earth orbits the Sun itself revolves around the Milky Way's center at approximately 143 miles per second, completing one full orbit in nearly 230 million years. This cosmic journey carries the Sun and by extension, Earth through different galactic environments. Interestingly, Stars closer to the galactic center orbit faster due to the stronger gravitational pull of the dense inner regions, much like planets closer to the Sun move faster than those farther away. To determine the Sun's speed relative to the galactic center, astronomers study newly formed stars that remain near their birth orbits. By averaging their motion, they estimate that the Sun drifts forward at about 3.1 miles per second, moves inward toward the center at roughly 5 miles per second, and rises out of the galactic disk at about 4.4 miles per second. These subtle movements significantly influence the Sun's trajectory through the galaxy. The Sun's orbit around the Milky Way is not a perfect circle but rather a slightly elliptical path that oscillates above and below the galactic plane. This oscillation occurs roughly every 60 million years and is influenced by the gravitational pull of stars, gas clouds, and dark matter. Currently, the Sun is several dozen light-years above the galactic plane. However, since more mass lies below us than above, gravitational forces are gradually slowing our upward motion. In a few million years, we will reach about 300 light-years above the plane before gravity halts our ascent and pulls us back downward. The vertical oscillation of the solar system is more than just a peculiar phenomenon, it may have significant consequences for life on Earth. Some astronomers support the Shiva hypothesis, which suggests a direct link between these oscillations and mass extinctions. As the solar system moves through the Milky Way, it periodically passes through the dense central regions of the galactic disk, where stars and radiation levels are higher. This increases the potential exposure to cosmic hazards, including supernova explosions and gamma-ray bursts. The movement of the galaxy's spiral arms remains an area of active research. Scientists theorize that these arms are shaped by a combination of factors, including the gravitational influence of nearby galaxies in the local group and the presence of density waves ripples that travel through the galactic disk. These waves can push stars and interstellar gas in and out of the spiral arms, potentially affecting the conditions on Earth. For instance, when the solar system moves through regions of higher density, the influx of cosmic rays and high-energy particles may influence Earth's climate, atmospheric chemistry, and even the evolution of life. The Sun itself is not stationary, it moves through the Milky Way, carrying Earth and the other planets along with it. However, every star in the galaxy is also in motion. A star's movement is described in terms of its proper motion, the apparent shift in its position across the sky over time, as seen from Earth. Proper motion results from a star's actual movement through space relative to the Sun and is typically measured in arcseconds per year. Studying proper motion allows astronomers to track stellar movements, providing valuable insights into the structure and dynamics of the Milky Way. Another important factor affecting our view of the cosmos is parallax, the apparent shift in the positions of nearby stars due to Earth's movement around the Sun. Because Earth occupies different positions in its orbit at different times of the year, our perspective of nearby stars changes slightly. The closer a star is, the more pronounced its parallax. By measuring this effect, astronomers can calculate the distances to nearby stars, which helps in mapping the galaxy's structure. In addition to parallax, the night sky is continuously changing due to the proper motion of stars. Over decades or centuries, the positions of stars shift, altering the familiar patterns of constellations. This means that the star arrangements we see today look different in the past and will continue to change in the future, reflecting the ever-evolving nature of our galaxy. The effect of proper motion is most noticeable in nearby stars with high velocities. Now that we have a breathtaking picture of how our solar system moves through the galaxy, one question remains: how do we move through the universe as a whole? The Milky Way is not alone in its journey. Our galaxy is constantly influenced by the gravitational fields of surrounding masses. We are currently racing toward the Andromeda galaxy at several hundred miles per second. However, this is just one part of a much larger motion. The Milky Way belongs to the local group, a collection of more than 54 galaxies, including Andromeda, all moving together through space. The local group, along with other galaxy clusters, is being pulled toward a massive gravitational anomaly known as the Great Attractor. This mysterious region, located about 150 million light-years away, exerts an immense gravitational pull, influencing galaxies across hundreds of millions of light-years. As a result, our local group is moving toward the Great Attractor at approximately 373 miles per second. Yet, this is not the final layer of Earth's motion in the cosmos. The entire universe is expanding, causing galaxies to drift apart not due to movement through space, but because space itself is stretching. This expansion is accelerating, further increasing the distances between galaxies over time. Despite all this motion, we can use the cosmic microwave background (CMB) radiation as a reference point to determine our speed relative to the universe. This faint radiation leftover heat from the Big Bang fills the cosmos almost uniformly. By measuring slight variations in the CMB, scientists have determined that Earth, along with our entire solar system, is moving at approximately 229 miles per second relative to this cosmic backdrop. At this point, it is no longer surprising that Earth is far from stationary. Instead, it is a small yet significant participant in a vast and intricate web of celestial motion. Our planet gracefully orbits the radiant sun, as it has for billions of years, but that's only the beginning. The entire solar system, with Earth as a passenger, hurtles through the vast expanse of the Milky Way, tracing a corkscrew pattern as it moves. Yet, even this is just one piece of a larger cosmic motion. The Milky Way belongs to a galactic assembly known as the local group, a collection of neighboring galaxies bound by gravity. Together, they drift through space, drawn toward an enigmatic force called the Great Attractor. This immense gravitational influence propels the local group at several hundred miles per second. But the motion doesn't stop there. The universe itself is expanding, a revelation first uncovered by Edwin Hubble in the 1920s. As a result, galaxies are rushing away from each other at astonishing speeds, stretching the very fabric of space. In the grand scheme of the cosmos, Earth is far more than a lone rock adrift in space. It is part of an intricate web of celestial movements, a participant in the vast, ever-unfolding story of the universe. Though we are but a tiny speck in the cosmic ocean, our journey through space is woven into the fabric of something truly awe-inspiring. Dear listener, please like, share and subscribe my channel for new audiobook. Thanks.